There we go. Hello, hello, guys. What's going on? Welcome back to the CAD Model of the Day show. As I fix my lighting, I look like I am one with the glowiness, so adjusting that here. There we go. I look like a person now. How's it going, guys? Good to see you again. Let's see here. We got Danielle. Hey, what's going on, Danielle? Good to have you here. Sebastian. Good old Sebastian. It's always a pleasure to see Sebastian. Also, I see DTMX10. You've been here before. Quick hijack to say, hi Danielle, love your work with kids and robotics. Yeah, I love it too. I think anyone with, with a playful spirit and there's a love of engineering will love Danielle's work. That's what it's all about. So good. And Tamborora Station, I see you. Good to have you here. Yeah, I think we're gonna work on a mechanism today. I'm gonna try and do mechanisms bi-weekly, and yeah, so I think it'll be a pretty fun. But before we do that, let's of course take a closer look at the Discord. And of course, as I always say, if you're not already part of the Discord, I recommend it. It's been such a great community so far. There's more and more people joining. Not only showing off the cool stuff, and you can see cool stuff here, but also getting their questions answered. I work a full-time job, so it's like I wish I could answer every question that comes my way. I try my best to do all of that on stream, but after that, I gotta work my job. So, in the community, there's like a bunch of people willing to help each other out. So, yeah, be sure to join. It'll be a good time. Daniel saying, "LOL, was the entire month of mechanisms not enough for you? Don't die." Yeah, I'll be fine. I think we'll make it good. And if anything, I learned from the month. I've learned to become pretty efficient at animating, and not only that, but editing too. Like, getting like the template on there, and getting that deliverable done. Hey, it's Joao. How's it going, Joao? All right. So what do we got here? We got some things in share your work. So don't mind if I do. And immediately I see some of Joao's stuff. Bro, that looks awesome. Is that? You 3D printed this. I'm trying to decide if this is like a 3D print or a render. At any rate, it looks great, man. Yeah, before it was the spring that Yaya did. The same CAD model of the day. Let's take a closer look at Joao's work. See if I can focus here for a minute. Bro, this is amazing. Looks like a perfect fit. That's awesome. Mini pen drive, extender plus the Vader I found on the internet. Yes, that's the nice thing with Solidworks. If you find some stuff, not only from just other Solidworks users, but from like video games, people will tend to rip the models out of video games and post them online, which I think is pretty cool. Hey Yaya, we're about to look at your thing next. I was looking at this Darth Vader thumb drive, very well put together, and Yaya saying he has debunked the famous chocolate trick. So let's take a look. Yeah, you can actually see it a lot better here. It's the power of CAD, because whenever you see this in a video, I don't know why every demonstration is like this, but they take the chocolate bar and like the dullest knife they could find. Like it's this plastic dollar store knife, and then the cut isn't very clean, so the effect is convincing, because like, oh look, it's the same number of squares, but here you can clearly see the conservation of mass. So this is a fantastic graphic. That's what SolidWorks is all about, man. It's just not only building, but communicating your ideas. And that's what I'm surprised about, like, old engineering is just like how to communicate this information without CAD was beyond me. Some real masters going on there. And he says, remade the springs animation with better camera movement, higher quality. I also changed the way it works to a mix between my method and Rob's. Well, it looks like you nailed it there. Dan Brewer is saying, I figured out how to modify an STL the other day. So happy to modify items I find on Thingiverse with Solidworks now. You know, all this modifying actually gets me thinking. Maybe I should find like a video game model and show you how I might try to convert that. But yeah, this is looking great. So, and then Johnny Joao saying, ooh, that's awesome. All right, what do we got here in tech help? All right, so this person says, I'm trouble getting a constant velocity in Inventor's dynamic simulation for rotary motion. Any tips on how not to make the rotation speed up exponentially? And this is very interesting, and this might, be out of my wheelhouse. So definitely, I have a handful of people watching. If you are, proficient in Inventor and you want to help this guy out, you can head over to the Discord and help us out. So that aside, I can tell you what I would check for if I were. Oops, I bonked the microphone. I do apologize. What I would look for, and it's very interesting. Like, at least in SolidWorks, there is that motor that by default has that constant velocity, right? But what I'm thinking is, one of the first things I would check is if this is like a very complicated system where maybe you have like gears spinning, meshing together, but then that system is like spinning on like an arm, so they're like doing this while they're spinning. You might have to check what direction is the rotation set. So in that case that I said before, let's pretend you have like an arm sticking out like that, and then on the end you have two gears that are turning, and then as they turn they just go like this. Me wiping away my tears after I fail my exam. But yeah, to get that rotation consistent, you need to say, oh, I want to power this gear with respect to the body that's turning, like that. If you don't do that, you do get weird effects like speeding up and slowing down all of a sudden. So, as an initial, check, that's what I would do. But yeah, if anyone knows Inventor, help a brother out. We got Alessio now. How's it going, dude? Glad to see you here. Yaya saying, when we rename, move, etc. part used in an assembly without using file utilities, we get a prompt while opening components asking us to suppress or browse and locate the missing file. Correct. This prompt usually lasts for 10 seconds, and after that we get a warning next to each missing component. Here we have two options. 1. Close that assembly, reopen it, get the prompt, and browse for the file. You don't actually have to do it for the... You don't actually have to do it from the prompt, but I'll expand on that. Or 2. Open the missing component from within the assembly, get a similar prompt, browse for file, rebuild, close the assembly, reopen, ta-da. My question is, does anyone know an easier way? Yeah, I can talk with that a little bit. First, let's see what we got in memes. Look at this dude. Let's see. Look at this dude. Yeah. Let's see this. Look at this dude. 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 That's amazing, man. No. It still is amazing after all this time. Yeah, I definitely felt the need. I know I started typing surface fill, but I'll send that. I'll send that there. Let's see. Yeah, that's yeah, I just like to be everyone's hype man, It's honestly, engineering can really be you know, I don't want to say like a thankless job, but it's a job that doesn't get as much glamour as it deserves. Like, there are so many amazing engineers out there that are basically like unknown. Like, you know, to us they're like rock stars, but you know, to the average person it's like, oh, it's a dude with a calculator, right? But no, I think it's important to celebrate basically every achievement. You know, especially one as monumental as achieving your expert. So, you know, I'm still impressed with that, dude. Don't let this buffoon tell you otherwise. Let's see. That's Twitter. Then you'll agree. I think it's cause many are too busy working to have a social media presence. I think so, and you know, that's, you know, I try to, you know, be a little bit different and like, you know, kind of like, how many engineering streamers are there? You know, I bet there's more, but you know, I think I run a pretty unique you know, content format here. And, you know, adding, if every engineer did what you did, we have a lot more ideas and collaboration. I think so too. I think not only is about, you know, celebrating, you know, engineering, basically engineering success, but also if you go at it with an open mind, basically, you know, I put a lot of effort into understanding Solidworks, but you know, I know that I'm nowhere near understanding it fully. You know what I mean? So I think just having that open mind and just celebrating when people have good ideas or have great models or great achievements, you know, that's the vibe we go for here in the Virtual Flat Cab channel. Yeah, it's a party now because Electrica is here. How's it going? Man, this is a real party going on. I'm enjoying this. Man, I've been very, very busy. You know, I'm you know, shout out to the people who are keeping the Discord running with not only, you know, showing off their work, but you know, the memes too. I love the memes, and yeah, you know, picking it back up where I dropped the ball, basically. You know, I forget who it was, but it was during the 2K stream. Whoever had that idea to make the virtual flat Discord server, you know, I gotta give him a real hand here. It's a great idea. Sebastian's saying, hey Rob, I have one question that I would like to know. What is the main difference between lofted boss bass and boundary boss bass? And lofted cut and boundary cut. Okay, we could probably do something like that. Perhaps there is no specific explanation for this, but will you have the same results using these features? This is a good, you know, I think this will be a good thing to test out. Alessia's saying, for materials like ABS, how should I estimate the yield strength, for example? Google it, but it's very confusing. Yeah, honestly, a lot of that comes with trial and error because it's not an isotropic material. Isotropic meaning that its strength values are the same no matter which way you pull it. So, for example, steel, you know, if you get a steel cube and you pull it from, you know, horizontally, it is the same as pulling it vertically, assuming that the geometry is the same. 3D printing is not like that because you have weaknesses in the build direction because you're basically putting layers upon layers. The plastic is weaker in that build direction. Like, it's easier to delaminate the plastic, you know, peel the layers off, for example, rather than snap the layers, you know, in half. Yeah, it's tough, but you know, I might ask one of my expert friends about that too, because he's a real simulation whiz. You know, he might have like a way of simulating bitropic materials, or at least doing calculations for them. Joao was saying, I'm only making SolidWorks models to use in 3D printing and trying to stay active in social media. You know, bro, I need to shout you out because you've been doing an amazing job. Let's check out what He has his Instagram is solid3d_, and man, you're doing pretty well. Look at that. You gained a lot of followers, dude. That's so good. But yeah, basically Joao over here is taking it upon himself to post daily, just like I do. And you've been really doing an amazing job. This is, you know, from someone who has been doing it for 500 days plus, it is very hard, and just to keep up with it is, you know, I am very, very impressed for at least, you know, more than 150 entries. A lot of cool stuff too, like the Pataras is very cool. Just don't throw it to Gohan, he won't catch them. But you know, I really love how these came out, the Patara earrings. Great work there. So, you know, Joao's our champion here. You know, this is hard to do. Just a sheer consistency. I like the themes of the stuff you do too. Oh wow, you got a little mini video too. That's cool. Yeah, that's top. I don't know why I guess I lost track of your page, dude, but you've been doing an amazing job. Awesome stuff. Alright, so let's answer some questions. I want to get to the one that Yaya asked. No, not that one. This one. So I think first, let's actually open up Solidworks. Don't know why I didn't do that. But, you know, it doesn't take very long to open. Thankfully. Hello? Oh, it went on my other screen. Come down. I have a quad display, and I swear it picks a new screen every time it opens. Let's see. Do we have any assemblies we could play around with? This one's, man, this one's not a good example because there's two components, including the spring. Like, these are just configurations that I did. Hang on, let me do this and then filter by assembly. We'll see what we've got. Let's do this one maybe. Alright, so I think this will work. Yeah, I think this will work here. CNC Kitchen on YouTube has some great strength test videos for 3D printing. That's good to know. We consider ABS for molding. Lego example. I read something like 20 to 60 megapascals with materials such variability. I should consider the minimum value. I think it's more than that. Like, if so I think the problem with simulating here, I'll get back to the I'll get back to this in a sec. So let's say we want to 3D print a sphere, and I'm probably gonna make this boy real chunky. Let's make that in like an inch. And what now? Do that. And let me say insert slicing, because I want to try and model this like accurate, like how a 3D print would come out, but maybe like zoomed in. So actually, let me change. Hello? Nah, didn't do anything. There we go. Oh no. Ah, son of a nasty. Alright, hold down control, click, let go of control. Would you like to delete? Yes, there we go. Yeah, because I want to do this. And then let's try slicing again. Because I think you can only slice in one direction. So slicing planes. So with respect to the top, let's make 5 planes. Maybe 10, but yeah, I'm trying to like represent the layers, right? How do I want to do this? Yeah, let's do that so we get a bunch of these things, and then oh, this is gonna suck. 0.5. So I'm just like trying to represent like the layers. Oh, man, I wish there was like a macro to do this. Yeah, let's just do it again. Yeah, it's not perfect, but it will demonstrate my point. So basically what I'm trying to say is, if you try and 3D print like a sphere, you know, because of how, you know, the 3D printing system works, like you might get something like this, where like this represents every layer, and that's why, you know, if you zoom in, it'll look something like this. Right. Though in my model it's very exaggerated. Why am I trying to fill it? My brain. Had a long day at work, but you know, we're just trucking. And let's just do one more. I think I can demonstrate my point with this many. Alright, so you 3D printed a sphere and you get like a microscope and you zoom in, and like these are how the layers look. So the thing is, with regular engineering analysis, well, you can't mirror exactly because the planes didn't go perfectly through. Well, the thing is, yeah, whatever way you want to do it. But to my point, engineering analysis is dependent, and especially a lot of like, you know, standard university problems, you know, what is the ultimate strength of a part, right? It's dependent on the strength of the material, right? But it's also dependent on the cross section. So what you'll have in university is like, you know, when you're doing a problem is like, okay, a rectangular steel bar is subjected to a tensile force. Calculate the stress and strain. You could do that. But with a 3D printed part, like as one as simple as a sphere, but you zoom in, look at how the cross section. So let's say we want to load it by picking this face and then pulling on it, right? So look what happens to the cross section. So it like undulates, right? It's just not very consistent. And that's what makes it so hard to run accurate engineering analyses on it. You don't have a consistent cross section to work with as one issue. Number two, a lot of not only strength testing, but durability, as in, you know, how many times can it flex without breaking, is dependent on surface finish. So it's just massively complicated for 3D printed parts, because those values that you found for Legos, it assumes that the Legos are solid and consistent throughout, which is true. When you injection mold something out of ABS, it is consistent wall thickness that you can apply engineering analysis to. Whereas with this, you not only have like, you know, layer lines to deal with, but you have different fill percentages and you know, inconsistent finish, right? So that's the big bane. A lot of it is just testing, honestly. Well, yeah, I might have modeled this inefficiently, but it was just for an example. All right. So hopefully that shed some light on that. Let's talk about Yaya's question. You see here we have an assembly, and let's open up the where this thing lives. Right. So we have something here called lens. And basically, when Solidworks opens up an assembly file, it basically has like a list of all of the members in the assembly, and then with the mates, it figures out how to put it together. So whenever you open an assembly file, it pulls out a list and says, I am looking for the part named lens. Lens, are you here? Oh yeah, you're here in the hard drive. Here, come on over. We need you for an assembly. And, places it there, and once it has all the parts, it will apply all the mates and the assembly will come together, right? So let's talk about renaming one of the parts. So maybe instead of lens, I want to rename this to like glass or something. So what Yaya was saying, if we close this assembly, I'll close that one too because I don't need it. And let's go back here. So rename a part without using file utilities. So I guess the simplest way or the naive way to go about it is you go to where it's stored in the file system. And where's lens? Lens, you press rename like F2 or right click rename and then say glass. All is well, right? Except when we try to open the assembly, one files were suppressed. We can even view a report. Instance of the following were suppressed or opened, and unable to locate the file for lens. So, yeah, it's missing. Here, you see that? It says cannot locate the file for the component to complete the operation. So what I wanted to mention here, Yaya was saying that you had to close down the assembly to bring the model back. You don't actually have to do that. All you have to do is right click, unsuppress. You do that and it brings you this dialog. So no closing required. Say browse for file and you say it's called glass. All is well, and we save. Everything is happy land. So how would I prevent this, dealing with those errors in the future? So I guess what's the proper way to rename? So typically you don't want to rename SolidWorks files just in the Explorer window, though there is a way to do that. So I guess one way we could do it, let's see, what way do we want to do it? So I guess one of my favorite ways, if you go to your options, go to Feature Manager, and you could say allow component files to be renamed from the Feature Manager tree. You can actually go here and rename them. So maybe I'll call it Glass 1 this time. You can temporarily rename the document, and then when you hit save, rename documents. Update where used references. Well, that's if you have like other assemblies that use the same file. So if you have like a bunch of assemblies of glass polishers, you want to do that, and then that should be good to go. Right mouse button, open file does the same too. I don't know I don't know exactly what you mean by that. Well, right click where, because you can the third way I was about to show. If I go here, if you right click, don't go to rename, go to SolidWorks rename, and you can rename this. Update where used. And then it correctly identifies that it is used here. And then when I should open this up, it should give us no problems. And indeed, no problems. You see it's named glass 2. So it just doesn't do anything. Let's yet another way. Oh, so I guess if you close this down, just save. Go here and, you realize that you renamed something without the proper way, right? Glass 3. And you anticipate this. So what you can do is, you can click, drag, hold Alt key for the open dialog. Yes, please. Go to references. Hello? Yeah, and then click glass 2. We replace it with glass 3. Open. There are many ways to do it. Yeah, so my preferred way, and the thing is I don't know your workflow, but if you have an assembly open and you have something that you want to rename, my recommendation, have feature manager, allow component files to be renamed. You can just, slow double click or click on it F2 like that, temporarily rename document, and then when you save, it'll commit the change to the hard drive. Oh, just a little bit of, Solidworks file management. So right click on the missing component, open, get the prompt. Yeah, that's basically what I did the first one. When you try to unsuppress, it brings that option up. But yeah, hopefully that helped a little bit, with SolidWorks file management. That can be pretty tricky. Let's see what else we got here. Okay, and oh yeah, I think the other question was in the chat. Let me see. Oh yeah, Sebastian's question here. What is the main difference between lofted base, boss, and boundary base? So they do calculate stuff a little bit differently, but the way I like to think of it, and the way I like to think of it. Let's I need to draw. I guess I could just draw here, right? Yeah, just get markup. I like to see it as a Venn diagram, and this is by no means, by no means extensive. Yeah, file utilities. Yeah, I think even more than that. It's just, if you don't have the assembly open, and that's why I say it's dependent on your workflow. Like if I have the assembly open and then want to rename, do it the way that I showed. But if you're just looking at files here, just right click, instead of go to rename, go to SolidWorks rename. You click that one, then it'll update the where used. Yeah. But loft versus boundary, a tale as old as time. I like to see it as a Venn diagram. Draw that circle. There we go. There we go. Loft. Bound. So what I think, when people try and compare loft and boundary together, they don't quite understand because, or when they try and find out what's so different about loft and boundary, it's easy to come to the conclusion, let's say, that they're both the same. And for a lot of cases, they are the same. But loft and boundary have some certain superpowers. So, for example, something that loft can do but boundary cannot is have centerline profiles. Oh my god, why am I trying to write? This is dumb. I'm so dumb. It's yeah. There we go. I love SolidWorks, but you don't want to try and overuse it. Now, shall we? Okay. Bruh, let me get that. Or that rounded rectangle. There we go. We got a circle. We got another circle. Look, it's a Venn diagram. Great. And you have a simple question after that. If I do an extrusion, then one over the top without merging, can I open the second extrusion in a new file? Yeah, of course. I do that, you know, with multi-body parts. Yeah, do that all the time. I can show you how to do that. Loft. Loft. Boundary. There we go. So something that loft can do and boundary cannot is have center lines. They both can have guide curves where they're guiding the edge of, you know, the shape they're trying to make. So guide. They both can have guide curves, but loft has a special superpower for center lines specifically. And let's say saying with boundary you can apply constraints. You can do that in loft too, but let's do constraints. Now let's get it going left to right. There we go. Constraints. Only. Let's do it. Only the start and the end. So if you have more than 2 profiles, you know, let's say 3, you can put constraints on only the start and the end for loft. For boundary, you can put constraints on all, profiles. But both can also render themselves as thin features. And those are really the big ones, the one that I tend to use for. I guess with loft, and I guess with loft, it weights the main profiles more than guides. So if you, especially with this one's more of a surfacing. Like if you're trying to bound a four-sided like square, you know, you make a little surface fill. But loft will kind of weight more of the shape towards one direction, and then the guides are kind of an afterthought. With boundary, weights the 2 curves, I'd say relatively equally. That's why they're called curve 1 and direction 1 and direction 2. You know, about equally. But yeah, Alessio's saying, yeah, I mean with two profile they are very close. That's what I'm saying. Like people just do it with 2 profiles and without any guide curves, for example, and they don't get it. But you know, loft and boundary at the end of the day have their own specialties. If you can get, I guess let's put it this way: you don't have to worry about accidentally using a loft when you should have used a boundary. If you can get the shape that you want with a boundary feature, then go for it. If it's got to be a loft, it's got to be a loft. Start a new sketch, draw some perfect circles, use the text of Solidworks equals love. Yeah, but yeah, I should have just done that. Oh, I thought this little mark was actually like a thing on my screen. I thought that was a bug. Just straight up. And now that I've like given like kind of this overall, you know, thing, let's, you know, put it into practice. I'll make up some examples here. Whoops. I don't spill my drink over me. Alright, so get that out of here. Okay. So for example, we'll do a circle. Going into here. You know, maybe I'll give it more space. There you go. And okay, a square circle. Okay, so we got that. Can hide. So for cases like this, you know, a lot of people go into Loft and do that. They might adjust this thing and alright, well, yeah, it looks a certain way, I guess. Okay, looks a certain way. Versus, you know, getting both of these and instead specifying boundary. And see if we can get the point in kind of the same place. Unchecked merge result. So we have two bodies like this. And I think this is a new feature in 2020. But if I go to evaluate, I can actually do body compare. This is new. So the source body will be a loft. The compare body, the boundary. And how do I want to see this? Current view. Everything is green. Oh, there we go. Let's see. Trying to make this easier to see. I haven't used this tool so much, but yeah, you can see that, you know, everywhere there's green corresponds to 0 on the legend. So basically, if it's blue, it means that the compare body, I believe, is protruding. And if it's red, it means the compare body is like, you know, puckered in. I can actually change the threshold of this. So if I make this like really sensitive, then we see some differences. So we can see that the boundary seems to expand 1/100th of an inch in this area more than the loft. So it's like very, that's such a minute difference, man. Like no one's gonna call you out and say, hey, you used a loft here instead of a boundary in this particular scenario. I never use this boundary. Yeah, I think loft gets all the attention. It's usually if you want to, if you want to merge two things together, it's usually the loft, and loft works really, really well. So where things start to break down, so that was good. So hopefully, you know, that was visually interesting. So let's get yet another plane like that. 12. And just for funsies, I hit it. I wanted to sketch on it. Let's get that same circle. All right, three profiles is where things start to get interesting. So if I use my loft, so say from here to here, back to here, and if I do the same thing with boundary, I would expect around the same thing. But if you go into loft, if you want to control the shape, you can only go from start to end. So I could say normal to profile, and you can play with these doodads if you want, but there's really no control you can get in that middle profile. Not true with boundary. With boundary, you see you get these neat little flags where you can say normal to profile, and this would have been like the same kind of result, but now I can go from here and say normal to profile, except it might be a little too much. Do you want to back out? Back off? Yeah, it might be, whoops. It might be a little too much for it to handle. There we go. Whoops, we got something there. There we go. And then back away. So you could see, you get this weird puckering thing. So you can't really get that specific effect with loft because you need to control this profile, and there's just really no options to. But what about, let's see, how am I gonna do this? Let's do that, and then let's get to spliny whiny. Start from here. You know what? Yeah, let's start the spliny whiny, but wait. Let's go like this. And then let me get loft. Get a center line. Yeah, I'm just building a little example here. Don't mind me. There we go. Let's try something like that. So just want to make sure with this, yeah, with this, I'd like to get it out of there. Oops, I copied it. There we go. Move. This I would like to pierce to that. And then maybe this plane, instead of just being there. Oops. Let's get this out. And maybe I'll do like this and that. So plane right on the end. Yeah, the convert entities is going to be angry, but I can just replace with just a straight up size. Come on, my dude. He doesn't want to move. Oop. Yeah, I mean, well, fine. We'll do it your way. Yeah. It is a trouble of leaving things underdefined, and I guess like not looking. Okay, you're gonna make me do this? Being a little whiny baby. There we go. Finally. Sometimes you just gotta get your filter out to enforce your will upon these sketch entities. There we go. I want to pierce specifically. So we got something like this. And if we try and boundary this, you know, from here, maybe to here, and then all the way to here, well, it looks kind of alright. Can I put this in direction 2? No, you can't. If you want to do this, you need to use a loft specifically. So, you know, you can start from this sketch here, going into that sketch there, going into this sketch. So you get kind of the same thing. Maybe you can adjust it like that. But with centerline parameters, you can put that and then, you know, maybe get a shape like that. So I think that's really the way the way to look at these things is it's really, you know, they both do very similar things, but they have their specialties, you know. So let's see. Never used the boundary. Yeah, we got that. Boundary is an inevitable while surfacing. Yeah, I think it's the most common type of patch because it weights both of the directions equally. Show some more examples of using boundary, please. Yeah, I guess it's really just about... Yeah, that thing looks kind of weird. Now it's clearer to me. Yeah, I'm just trying to think of a good boundary example. Yeah, and I think the best way, honestly, is just, you know, you have an example with multiple, yeah, you know what? That reminds me. Show you guys something cool. You guys like cool things, right? if I go to solidworks.com/training file, training files, Solidworks, here, and I'll post that in the chat just in case anyone wants to take a closer look at it. Has anyone used this before? So you go to this link, and what? Oh, okay. You go to this link, and you can actually download example files from any SolidWorks training manual. So you may already know is that the training manuals are only for like reseller like courses. Like you can't. There's no online bookstore for these, unfortunately. I wish there were, but what is really nice is that the files themselves are open to the public. And there was a great example when I taught the advanced part modeling course. So I'm gonna get the advanced part modeling classes, and for some reason, you know, they package them in executables. Yeah, Andrew Lowe is very good. I learned a lot from him, especially his 2014 presentation. Oh, why did I get like 3 of these? Okay, we're gonna get some files, unzip. Okay, 236 files zipped successfully. So if I go into my C drive, yeah, for some reason it dumps it into the C drive. SolidWorks training files, advanced part. What lesson was it? Was it lesson 8? Case study? No, this is the, well, I guess you could use it with that too. But I want lesson 9. Case study. Completed case study. No, let's do... You know, so here's a good example of using boundary. So you can see that we have multiple profiles that we may want to control individually. So we'll get the boundary, you know, start there and go, whoop. Try not to click on the guide curve, then go to there, then go there, and there. And then you see all those flags popping up like that. And with boundary, you can also put guide curve directions. Hello? Yes? Okay. It's looking a little crunchy there. Looking a little crunchy. You know, can get something like that. And then with all these multiple profiles, you can continue to refine. Oh, that's not going to work. You can kind of continue to refine using, you know, whatever, you know, kinds of adjustments. So boundary shines when you have multiple profiles. Also very interesting is that boundary is able to extend profiles past their last profile. So you can see here, this is the last profile, but because the guide curves kept going, boundary is able to extend this. Loft isn't able to do that. So if this rare situation comes up, you might want to consider. But other than that, you can trim by direction 1, which means when the profile ends, the profile ends, and yeah. So I think people really like to see that one when, you know, kind of visualizing where boundary actually works. And then I would say for the cuts, it's the same thing, but you're just removing material. But yeah, same implications. So hopefully that answered your question. That is a great one. And actually, I go over it a little bit too. Here, I'll show you. It's in Andrew Lowe's video, but it's also, I do it in mine as well. I go here. And go to my channel. It's in the CSW yeah, the secret techniques. Oh, look how vintage this is, man. I think I put it. Yeah, look at me. I'm such a Chad. I put all the tips in the description. Oh, law versus boundary. It's the first one. So if you wanna see me explain a little bit more, but this is more when it pertains to surfacing. I know the question was more about the actual features themselves, but yeah, I think you'll like this video. I show a couple surfacing examples there. All right, and I think that's it for the questions. If no one has anything else, so I think I'll look for the actual model of the day to do. Sir. Let's put this here. I might. Oh, do you guys know how to fix this? If you do a shadow and it disappears out of nowhere, you guys know how to fix that? I'll show you right now. Go to Scene, Edit Scene, Align Floor Width. You can say Selected Plane, and align that sucker with this. And now your shadow is in the correct place. I see a lot of posts where like the shadows are like disjoint, so I thought I'd share that little tidbit. I guess I'll put this out in anticipate. Oh, I put goof by accident. I probably should take out goof. Though we like goof. Yeah, but I was thinking of just going to 507 movements. I might go for something simple today, honestly, because it's been a long day. But I can't fail to disappoint. I don't want to disappoint. I do have that engineering spirit, but I also like sleep. And I'm sure that there are those of you in the chat like, sleep, what's that? My professors haven't let me sleep since the fall of 2017. I did 96. I could do 97 because I did 96 like off camera. Though the method is very similar to making the 3-lobed cam that I did the other time. I'll keep that in my back pocket. If I can't find anything, I'll fall back to that. Or I could just do the screw. This one you could do with trace pass also. If you need to get a cam that actually, I kind of want to do this one. Nope, don't look at it. A cam acting between two friction rollers in a yoke has been used to give movement to the valve of a steam engine. What's very interesting about this is that this drawing implies that both wheels should be in contact with the cam. And then you can give whatever valve movement you want from that, which I think is very interesting. I like this one too. I like this one better than the other one, so I'll keep that one in my back pocket, but I'll keep looking. I did this one already. I want to do this one, the Chinese windlass. It's the press. I did 130 a long time ago. Did 135, did 136. 137 looks like the same as... Hold on. Expansion eccentric, used in France to work the slide valve of a steam engine. The eccentric is fixed on the crankshaft. I see that. There's a key. And communicates motion to the forked vibrating arm to the bottom of which the valve rod is attached. Yeah, I'm not really 100% getting this because I do see there's the eccentric. It's touching these two rollers. So is this pin fixed in place? So when this moves up and down, Should this rotate about this point like this? Or is this free in free space and this whole thing moves as one unit? Additionally, what's the deal with this? Same question for that. I suspect that's the reason that this hasn't been animated. It's not very clear, at least in my opinion. Maybe some of you in the chat will beg to disagree and I'm just being potato, but... What is that? A valve motion for working steam expansively. A series of cams with varying throw are movable lengthwise so that they may... so either may be made to act upon the lever. So Tamburoro is saying, I think there's a pivot not shown in that picture. Oh, maybe out to the right you're saying? Like this extends all the way out here and there's like a pivot? Yeah, it could be. This comment is interesting. What if I type in just slide valve of a steam engine? Hello? Yeah, I don't think I'm gonna need a lot of hits here. Yeah, nothing that I really need. But what's interesting is that when usually some things are like foreshortened, they're usually given a jagged look to them. But I see what you're saying too. Like it's like something that's foreshortened looks like this, like in the very same image. Like you see how the cut isn't perfect, it's like all jagged. Same with this one. And yet this one is like, it's like perfect. Why is it like that? Yeah, I mean, I'm really not sure about that one. That's kind of interesting. I think I want to do 117. I like how just most of the stream is just me looking. Just me looking at pictures. Though, how do I want to draw it as... Yeah, I kind of want to do this in full detail, but I might do it on the weekend, actually. Yeah, I think let's go for the cam, I would say. Because, you know, I think... Because I did 96 without anyone looking. I did that on an off day during the month of mechanical movements. So, I'll show you how it's done from start to finish. So, I think, well, let's actually save that image. Put that here, we'll copy and paste. Yeah, there we go. Look at that paste. So I think let's start working on the follower itself. With the follower, I think that's supposed to be... It's not drawn very well, like inside the track. But we could do it just simply as just like, you know, a slot. You know, maybe I'll do this one in millimeters, why not? Just say radius of 10, sure. And then a length of 200. Oh, 200. And let's extrude out to just one direction. 10, that's fine. And we'll maybe convert and then grab this doodad and make it go like loopy. And then extrude that the other way. And then we can have a hole, maybe a countersunk hole just to make it look like something. Let's position it first like that. So through all, oops, that's too big. Let's do metric. Let's do an M3. There we go. Then maybe I want to like chamfer this. Come on, chamfer. 2 like that. And then make that into like steel. And put that there, and just for some visual like, you know, interest, you know, make that like brass. And I might have to make that like way longer, because I do want the end to like kind of stick out. Like that, and then let's go into here, follower. And then the wheel, but the wheel needs an important piece of information, and it's, what does that curve look like? I don't quite have that information yet. But what we can do, how do we want to do this? Let's get an assembly. Let's get the follower in there, and I'll say new part. So I'm gonna make a dummy part, or actually let me just bring in goof. Goof, get in here. Can always count on goof. Save. Dummy. It's just to help us set up our motion study. That will, you know, with trace path, will get what that looks like. So let's get rid of that. We don't need that. Insert dummy. Let's get the front. Let me put an axis. So it's between the top and maybe the right plane. I would like an axis. It's like way down there. So front with the axis be in the same place, but it also needs front with the front plane of the assembly. There we go. And that is fixed, so remember to float that. And yeah. I can make a book on animation and dummy parts. Do it. Do it, dude. Let's get the top plane. And the top plane of that. Take the same, and the front plane. Let's do the front plane of the follower together. Alright, so now we have this. And, you know, there's more than one heart cam you can have. So if I paste, can I paste this image? Oh, there it is. So let me take a look at this. This isn't the only heart cam there is, because this is all has to do with the character of this motion. You can actually start the heart, like for example out here, and then go way out here, or you can go really close to the rotation point. I think there needs to be a little bit of space, so I might, here, let me start. I'm gonna put some mates to help lock this up, and then I'll say that, and this can be tangent. So if I ever need to reset it, I can do it just like that. And suppress, motion study, make that into, well, I gotta turn on the add-in. Motion, you do need motion for this. They're the secret sauce in the most cool animations. They really are. I think my most cool animations involve, or at least me personally, like the animations that I think are the coolest have at least one dummy part in there, like doing something really weird, you know. Um, but yeah, with the dummy part, I can say rotate the front just to make this easy. I might do 6 RPM, so that'll be 1 revolution every 10 seconds. So we can test. I think the follower's gonna fly away though. Let's see. Yeah, you see it's like kind of scooting around, but it's doing what we expect. Oh, let me also set this to motion analysis because we'll need that soon. Yeah, now it's flying away. That's what I expected to happen. Goodbye, follower. You're not coming back. I once rendered my animation without hiding my dummy part. I've done that too. I have absolutely done that too. Nothing's more sad than, you know, thinking you're done with a CAD model of the day and then you notice like an artifact in it. I've actually had to delete some posts and redo it because I'm like potato. So yeah, you know, back to that inventor guy's question, you know, what's really important here, if I put a linear actuator and give it a direction, it's really important, since this is on a rotating body, that you specify with what part is it rotating with respect to. So in this case, it's this one. I could say oscillating, and I could say 0.1. That'll be 1. That'll be 1 cycle every 10 seconds. And maybe make that like 5 inches or something. So let's come out all the way 5 inches and then come back the same. Why is this so slow? I made it too slow. Oh, I guess it's calculating, right? I shouldn't be so impatient. I was told my reaction was priceless. You know, sometimes it's like whoopsie doodles, but if you're like, you know, stressed out and you need to like, you're like, I gotta get something out. You know, it can be very heartbreaking to find that. Alright, let's get a point at the center of that, so I can actually trace where that thing goes. What is this? Diameter of 20 millimeters. Forgot. Oh, I guess I should... Oops. Big oof. Oh, I guess... Let's make it a good value. Like a good value. Yeah, let's go. Let's go, boy. Nice. So we have that, and if I go to results, displacement, trace path, and in the assembly, which I haven't saved yet, can do that, for example. Well, that's a little bit of a heart, I guess. I guess I would get more of an extreme heart if I started it. Oops. Yeah, I took this. Yeah, I guess it doesn't really matter. Started it closer to the point of rotation. I would expect a more extreme heart. Looks like it's it's like almost going into orbit. Totally see that, dude. Yeah, so that's definitely a more extreme heart. I was wondering, I wonder if I change the character. If I go to this, and instead of oscillating, I put like data points or something like that. And say displacement with an Akima spline. Remember, this is 10, so it has to go to 150 at some point. You know, most likely by the time it hits, well, let's do 10 there, and then if I say insert row above, it'll split the difference. Oops. You know, so that could be a certain character. Will you add the sharp point at the bottom of the heart manually? Probably not. The curve should take care of it. Like this one is resulting in a sharper heart. So you get something like that. Or we can keep playing with the interpolations, which I might for a bit. Insert row, insert row. So something like that. I would expect to be a lot harsher. Let's see. Yeah, so it just stays there, and then it's gonna suddenly come out. Oh my goodness, I think this is going to be not safe for work. Okay, it's not as bad as I expected. That could have been a lot worse, I think. It just looks like a flower petal. I don't know why I was so scared about it. I thought I was going to get demonetized here. That is very interesting though. Put more dwell time for the 150. I wonder what that would look like. We'd actually have to go backwards. It's a fun time to experiment. Okay, that is like not physically possible because it is crossing the yeah, it's crossing the axis of rotation and you can't do that. Yep, figures. That looks, well, cool. I don't think it'll translate very well into an actual path. What I do, just say like insert row above. So this one's like a more, closer to a square wave. It's really interesting. Hearts have 2 sharp points. Trace path only makes 1 at the top. I suppose so. The thing is, I think what the mechanism intended is like more than, I think heart is just like a name for it. Like I think you just want to like accelerate and decelerate smoothly, and sine wave is probably the best characteristic for this to have, but we can try for it. You know, so to make a sharp point, there would have to be a discontinuity at, its maximum value. So if I go back to here, for example, and I might just delete a bunch of these rows. The 5 can stay. So instead of an Akima spline, what if I just do a linear like that? So I think that might do the, whoops, I goofed up. Come back. So this is linear speed. So because it's changing velocities instantly, you should get a sharp. And that does seem to be the case. It's pretty close to what's in here. Yeah, I don't know. I think I might go with that, though. I'm gonna do one more edit because I know this dummy part is in inches. So let's make this like 25. Yeah, exactly. Now that's a real. Oh man, I miss the Valentine's Day post by a couple months, but you know, it's never too late, I guess. Let's do that. Bring that into motion study. Can we turn these on? Unsuppress. Unsuppress. Oops. I did that at the very end, though. I'm just gonna suppress, unsuppress. Put that out to 10. Oh, whoops. How about I try? Yeah, let me try something here. Something I've always wondered. Check out the awesome GIF on Discord. Sure. In the general chat. Alright. Now let me look at this. Fixed on the pivot X. Oh, I see what you're saying there. You know, there are mistakes in that book. Like, you know, there's typographical errors among other things, and yeah, so it could be that he's just missing something. Oh yeah, the steam engine. Amazing. I like how it specifies it's from boiler, but only at certain parts. Hot steam. Well, I guess it is from the boiler, right? But, yeah. Suppress. Unsuppress. I like the way this looks. Okay, so let's take that and create curve from path in new part specifically. When are you gonna bring the zip ties back? Oh my god, that was such a meme. Huge meme. Yeah, so long story short, you know, I really got into, like, you know, I guess it's like security. Let's just making sure, like, you know, I like locks and safes and other security systems. I think they're pretty cool to figure out the engineering challenge of letting someone who, you know, has a certain item like a key or knows something like a code access a space but not others. I think that's a very interesting challenge. And basically, I 3D printed zip ties to put on my luggage one time because, you know, if they cut them and looked inside of my bag, they couldn't replace them with regular old zip ties because, like, I would know you can't have these anywhere. They're special zip ties. So yeah, I 3D printed zip ties at one point in my life, and it was very memey. You know, Danielle definitely enjoyed it. She got a kick out of it. But yeah. By far, I don't know, dude. By far the nerdiest thing I've ever done. Come on, man. Like I've done a lot of things, a lot of nerdy things. This does not want to offset. No, by far. I'm saying you've known me for a while. Are you sure there's literally nothing else nerdier than that I've done? I mean, it's definitely a top pick, I would say. Our next bot will have custom zip ties. Yeah, we gotta get back to designing that bot. Can I do 20? That would be super freaking dope. Oh no, what is it doing? Alright, I might try. What will I try? You'll never know what I'll try. Where's this sketch? Convert. Trim. Let's do that. Former nerd admits to making nerdy things. Yep, you heard it here first, folks. I mean, this channel used to be called the Solidworks Nerd, so, you know, make with that with what you will. No, you goofy idiot. I meant pick the other sketch. You silly goose. It hates it. Does not like that. Does not like that sharp at all. I mean, I could make the sharp, the follower just a little bit narrower, but that's the quitter's route. Am I a quitter? I don't know. Maybe. We'll find out. 20 millimeters. So let me try a couple things. This about this, sir. You hate it. Why do you hate this? Alright, I wonder if Loft can help us out here. That'd be kind of funny. We talked about it. Did you see the viral tweet about Adobe charging a huge cancellation fee? No, I didn't. Well, actually, I think I saw it in the sidebar in Twitter, but you know, I was busy at work, so I didn't really get to see it all that much. That is some strange behavior. Oh, gross. That's probably what's causing all the drama in this part, at least. You're making me very curious, but I wanna fix this. I mean, something we could try. So that's definitely it there. You know, it's such a drastic change in curvature. I mean, we could try to... Yeah, we could try and just like cut it off a bit, but could also talk about, you know, let's make this into a lesson of, what's it called? Show you how to spline sketch. If you cancel within 14 days of your initial order, you'll be fully refunded. Should you cancel 14 days after, you'll be charged a lump sum of 50% of your remaining obligations. That sucks. Your service will continue until the end of that month's billing period. Wow, that sounds fun. Yeah, whenever you know, I'm not sponsored by these guys, by the way, but there's a service, privacy.com, which, you know, you can link a credit card and make virtual credit cards, which you can destroy. You know, so if you want to sign up for a free trial and you're afraid they're gonna, you know, give you hell to unsubscribe, you know, you can start the free trial on a virtual card, and then when it comes time to renew, you just go to privacy.com, destroy the virtual card, and they can't charge it. It's pretty smart idea, I think. You know, I just have a free plan, and, you know, it's like a limited amount of cards, but I've used it a couple times when it's like, oh, I want that, but this website is so suspicious. Man. All right. So here's a lesson of the day. You see how I'm struggling with this style spline to try and get it to match up? I eventually do want to get it into a style spline because I like the curvature control a little bit better. So what you can do, spline, just get a regular spline, which, you know, by and large are way easier to control. You know, get it kind of close. Should be doing this side. Get it kind of close. I'm just gonna trace. And then, yeah, convert to won't work here, yeah, because it'll also convert the garbage as well. I'm getting a new spline because the other one's being stupid. Then you can right click and then say convert into style spline. You might have to adjust some things, but, you know, at least it'll be very, very close. Yeah, so I'm just going for a trace, and I think what would be interesting is see how much of the original curve we can get back. So I think that is pretty close. I may be undershooting it here a little bit. Oh yeah, that's what I was about to show. So you weren't just talking about another thing. You were just ahead of me. Was all. Wanted to write it faster than you'll say it. This kid's trying to beat me to the punch. Well, thanks to YouTube chat lag, I've got the upper hand. Haha. Yeah, but that's a trick that I wanted to show, which I think is very, very helpful. So you can see it's not exact, but I think this will be very interesting to, you know, see what kind of character we get from, you know, the resulting cam. Did that get a horizontal? That's not good. Get rid of that. Yeah, so you can see it's like not exactly in place, and as I put these, there we go. So that was just causing all the issues. So this line is true, it does really go through the origin. If I show the original curve, you know, I could put more points in it, but you know, I think that's good enough. And actually at that point, mirror, and yeah, I'm gonna do Yaya's favorite thing, which is to fully define sketch. Hooray, look how terrible it is. There we go. So now we know it's not going to scoot around on us. I wonder if I can actually perform the offset entities from here. Oh, I might be grabbing the wrong thing. Let me hide. Offset. Oop. Said offset, sir. Alright, so that's a lot better. Bidirectional. There we go. I probably need to fill it. we go. Select chain. Oh, that's in a different sketch. Why does it have a font like that? That's very, very interesting. All right, so we'll keep that there. This was not easier than trace path. What was the purpose of using trace path? To get the start. Because without trace path, I don't know the overall shape that gives me that characteristics of having constant velocity go back and forth. Because you could sketch a heart like this, but you know, will it actually make it go at constant speed without accelerating throughout its motion? I think trace path was still helpful here, which is that's a good question, you know. Oops. I have so many random sketches. So I need something basically like that. Hello? Okay. 390. This thing's huge. Jesus Christ. Man, this is... Let me check something. Yeah, that's 20 millimeters, so... Okay, I guess it's just kind of big, I guess. Yeah, exactly. You want to... Because, it's like I was saying earlier, it's like... this is not the only heart you can have. Like, you can have one that, you know, speeds up, accelerates, and then suddenly stops, or... That's what I was playing around with trace path. Where you can have one with a sine wave. The one that, you know, didn't really have like a sharp point. You know, that smoothly transitions. That's why there was no sharp. But yeah. You know what I could do? I'm sketching this. I don't know if it's gonna make... I mean, I could always use contour select. Yeah, let's just make it 400. 400. How did it look like again? Yeah, it's really tough to tell if the... I mean, of course, that can't be a through slot because then you just cut the thing in two. So that has to be a recess. So you can take that again. Just go the other way. So you get something like this. And I think I can fill it here. The radius of 10, that's the follower. So then I have more space to do something with this. There we go. Get this all lined up. You might have a small hole. That's very funny. Just give that a through all. Yeah, I know this has this thing, but I think I designed it with the path being a little too close, but you know, without doing a whole bunch of changes. Well, you know what I could do? You know, let me boost this up to 20, first of all. Because I think there is space for that, at the very least. And we can convert. Oops. My goodness. 15, sure. And then I can convert. And let's just trim. Doink. Make that like 5. I don't know, make it look like something, you know. So how do I want to do this? I always ask the same questions because I want to make this so let's assume the whole thing is cast because I'm not going to have ambient occlusion on, I don't think. So we cast the whole thing, but then machine out this path. Let's turn off ambient occlusion. And then I would expect to machine the face of this. There we go. That looks like a thing. Just one giant dark wheel. Follower wheel. Okay. Now let's get this. Let's put this into a separate assembly. When an engineer meets a machinist. Yeah, it's a full knuckle brawl, just letting you know. By the way, like, here, I'll take a quick detour to show you something funny. Like, I don't know if you guys, hang on, documents. Use my custom sheet format. Look at that. Wow, reppin' myself. Look how good that looks. Anyway. Wheel. Okay. You have something like that. There are some really, really mean patterns you can use to hatch something. So if I get like area hatch and then pick that, you're like, oh, okay, cool. What's the big deal? Isn't that just a regular hatch? Well, there's a lot of really interesting patterns, to say the least. My favorite is Escher, if I can find it. Oh yeah, look at that. Now that's a pattern any machinist would love to see on a print. My god, my brain is just melting just looking at it. So yeah, if an engineer is making fun of you for, I don't know, for being at a desk or something, you know, just send them a print that looks like this. Be like, I hold all the cards. Too funny. But yeah, let's float this. Mind blown. I'm glad you like that one. I can't. I mean, Yaya's to the point where I can't show him like actual tricks because, you know, he's been studying for so long that everything is just like, you know, whatever to him. But I'm glad this one thing has struck a chord with him. Can we get let's get a axis. And then additionally the same thing here. That should definitely be on the drawing tools exam. I think SolidWorks Corp would get like so many complaints. They're like, why did you show so many engineers this dumb trick? I am out here losing my marbles, and it's all your fault. You know what's interesting? If I go into here, and if I fillet this corner, right? I could probably just get away with a tangent mate. or not a tangent, a cam mate. Though I've gotten some iffy results from that. So let's see. Insert follower. Well-mentioned drawing tools need real revamping. Yeah, it's been a while since I've seen any of that. Let's go back to this. I might make this thing two-sided, so let's change this to mid-plane. Okay, and mirror at the front. Okay, so it looks like that. And then, what now? And. Yeah, the plane of the assembly, so that's good. And then I can say, what else? This and that. Don't be shy. Are those actually not made? Okay, they are. Okay, they were just being annoying. Well, anyway, that's fine, I guess, because I go to advanced. Or is it mechanical? Cam. Yeah, there we are. Cam path. I think you can click on just one of these. Hello? Is there still is this thing messing with it? Oh, I guess it works when I click on there. And then the follower should be this. Mate. Selected faces do not form a closed. Alright, well, I got a workaround. I mean, I could just use regular solid body contact, but let's see if we can't get that made to work. So let's get a sketch on the front plane. Select tangency. And I think I can just go straight to fit spline. So you can put a fit spline, close spline, that is correct, constrained. And now we can go to surfaces. So this should be guaranteed, basically, to be tangent. And very usable. So now we have a surface there. Going back here. I can say mate cam path and the cam follower. So you could just pick any one of these, and that seems to be working pretty well. This might result in errors. All right, well, let's see. Let's see what they are. Oh, okay. Nice. It seems to have nestled itself in there. Why did we take fit spline away from command? Hey, it's Sean. Sean, how's it going, my man? So good to see you. Yeah, why did they take away fit spline from command manager? Am I right? Didn't make a bit of difference though, because this thing is fighting me. All right. Hello. If I do that and then reattach, what happens now? Okay. Okay. And. Okay, now. Okay, it works now. All right, quick. Nobody move. Nobody breathe. Okay, breathe. That's important. Vital function. We can hide this. I can't tell you how happy I am to have the Sean in my stream. That's just amazing. Yeah, for those of you guys who don't know, Sean O'Neill, if you guys love like the community aspect about SolidWorks. Like he's like, you know, a leader in the community, and it's awesome. If you're a SolidWorks champion, you definitely know who he is as well. But yeah, let's bring this to a motion study. Oops, no, that's not what I wanted. No spring today. Let's do that. Okay. And I'm pretty confident in this, so I'm just gonna bump the frame rate all the way up. Huh. Okay. Nice. So yeah, he's asking why use a quad monitor setup, squinty face. Yeah, it's my preference. It's I think, yeah, I'm just kind of surprised I've been using it for without it so long, and because like I do like a lot of like multitasking and stuff like that. Okay, so this is going pretty poorly, I would say. So let's just get rid of that. Motion analysis. Okay, we got the motor already, but we want this to bonk with that. There we go. Yeah, of course. I mean, if you're wondering why it's so easy for me to respond to your chat, to respond to your message, you know, I have that in an area of my screen. Then I can also easily switch the volume of my music, which I've done several times this stream. If you haven't noticed, can also check the health of the stream. So you know, if my stream goes down, I'm not just talking to a brick wall. For streaming, it is super extremely helpful. I've used dual monitors for a while and I'm already in neck pain. I think the important thing is I actually, you know, had a little bit of neck pain with the quad. Getting a chair with a back, like a gaming chair, very helpful for that. It makes it super comfortable. At least for me. But yeah, it does look like we're coming to the end here. Tamborar with a triple. I mean, that's also yeah, my chair broke. It's very sad. I might have to buy a part for it. I don't want to buy a new chair, honestly. Are the ultra wide monitors better? Honestly, if you can get an ultra wide monitor, they are awesome for assemblies. And I don't know if there's a way I could easily show you. Maybe, yeah, hold on. Let me do one thing. Let's save this out first, and I'll see if I can try and get my other monitor on stream and not tank my frame rate. We'll see. We'll see. That looks pretty good. Give that 60. Let her rip, and in the meantime, let me go to OBS and see if we can't get a new screen, right? New display capture. Ultra wide. No. Yes. So I'll peel back the curtain here a little bit. You know, so for those of you who don't know, this is about how widescreen looks like. So let me turn off the old screen. So it looks like that. So it's absolutely terrible for streaming, but for SolidWorks work, what I really love about it, you know, if you get the SolidWorks screen and you put it over here, boink, come on, boink, I said, there we go. you can work on your model and have this thing all the way pulled out with this. So if you have long file names in the tree, you can pull out your feature manager like all the way out here, be able to read it, everything, and still be able to work. And especially important if you have like this thing, you know, if you have custom properties. You know, the effective what's it called, graphics area is like a 1080 monitor, but with the ultra wide you can have these panes around it and, you know, still comfortably work. So, you know, if you threaten me, gun to my head, what one monitor out of the four would you prefer? I would actually prefer the ultra wide rather than my 4K, to be honest. And also, you know, with this just the one monitor, you can break them up into two like this. So it's like effectively like two monitors in one. So if you want to chip out for one monitor, you know, having an ultra wide is I think is a pretty good deal in many cases. But yeah, I will. Let me change my get that. Ha! Now you guys can't see anything. There you go. Okay, that wasn't absolutely terrible. I'm getting better with OBS, but let's see how the thing came out. I did this all without saving. I'm an actual madman. Hang on. What movement is this? 97? Bruh. Where did I actually save this? I'm so potato. Okay, so it is called Ascem 2. Man, I'm such a mad lad. I did that without saving. So let's see what this looks like. And if it looks good, you know, we'll wrap it up. We'll call it a stream. Looks like it might have a little stutter at the end there. I wonder if that's just Windows Media Player though. Always hard to tell. Well, that stutter is very easily fixable in Camtasia, so that's what I'll probably do. So, yeah, for those of you who stuck by and watched, or if you just came by, I really appreciate you coming here. I think we're gonna end off this episode here. So before I go, of course, allow me to remind you, if you don't mind, of my social medias. Of course, you can consume my content anywhere, you know, especially YouTube, but I'm also on Instagram and Twitter. You know, so that link tree will bring you to this page where it's just like a directory of all of my stuff. And I would love to see you at the Discord. You know, so let me give you the link to the Discord. Discord, to reiterate, it's just, you know, the community that we've built all together. You know, we share memes. We share like just cool stuff. We ask questions. We answer questions. It's a great community. You can also get notified of my streams. I'd love to see you there. So, you know, with that, you know, thank you so much for watching, and I will see you. Today's Tuesday. I will see you Thursday. Bye, guys.